You know when you watch an AI solve a problem and it has that little aha moment? It feels like you're peeking inside its brain, right? But what if that's all just a show? Well, researchers are digging into that exact question, and honestly, what they're finding could flip how we think about AI on its head. So here's what we do. We throw these really tough problems at these AI models. We're talking complex math, tricky coding puzzles, you name it. And we're not just looking for the answer. No, we want them to show their work. We want the full story of how they got there. And they totally do. They lay out their reasoning step by step in something called a chain of thought. It looks exactly like a student's homework, right? Step 1, then step 2. It all seems so logical, so transparent. And it makes us feel pretty confident in the answer it spits out. Okay, but here's the kicker. The really big question researchers are tackling now is that chain of thought real? Are we actually seeing the AI think? Or is it just putting on a good performance, telling us a believable story, while the real calculations are happening somewhere hidden, behind the curtain? Right, so for a while, we've all been running on this huge assumption that this step-by-step process is the AI's real, unfiltered inner monologue. But some new research is suggesting that, well, it might just be a very convincing illusion. And hey, this wasn't some fringe idea. The entire research community kind of bought into it. As one major paper puts it, the common thinking was that this chain of thought is like a scratch pad where the model thinks out loud. That belief has been the bedrock for how we've tried to build and understand these things. And you know, this isn't just some dusty academic argument. This idea of faithfulness is absolutely critical. I mean, think about it. If we can't trust that the AI's explanation matches its actual process, how on earth can we monitor it for dangerous behavior? How can we ever really truly trust what it tells us? So, to finally get to the bottom of this mystery, researchers came up with this really clever new way of looking at the problem. They basically decided, okay, let's stop taking the AI at its word and start measuring the actual impact of every single step it takes. They split the AI's reasoning into two buckets. First, you've got true thinking. These are the steps that are absolutely essential, the ones that causally affect the final answer. You mess with one of these, the whole thing falls apart. But then you have decorative thinking. These are the steps that look like reasoning, they sound plausible, but they're just window dressing. They have almost no real influence on the final outcome. Just look at these two examples. On the left, you see a perfect decorative moment. The AI spots its own mistake, that's the aha, but then it just ignores its own advice and gives the wrong answer anyway. It's wild. But on the right, you see true thinking in action. It finds the error, it follows through on the correction, and it gets the right answer. The process looks similar, but the results couldn't be more different. Okay, so this idea of true versus decorative thinking is a game changer. But how do you actually measure it, right? How do you put a number on just how true a thought really is? Well, that's where things get even more clever. They came up with this dead simple but super powerful test. It's basically 3 steps. 1, you pick a single step in the AI's reasoning. 2, you poke it. Just gently change a number or a key word in that one step. And 3, you just sit back and see what happens. Does the final answer change? If it flips, you know that was a critical step. If nothing happens, well, it was probably just for show. Now, as you can probably guess, the actual science behind this gets pretty complicated. Researchers run these tests they call necessity and sufficiency, basically asking, was this step needed, and was this step enough? By doing all this, they can boil it all down to one single powerful metric for every single step, the True Thinking Score, or TTS. It's literally a score for how much a thought actually mattered. So now they had the tool. They could literally go through an AI's homework, line by line, and grade every single thought. And what they found? Well, let's just say it was not what anyone was expecting. Which brings us to the big reveal. After all this work, how much of that long, detailed, step-by-step reasoning is just a performance? How much of it is fluff? Get ready for this. 2.3%. That's it. Just let that number sink in for a second. When they ran their tests on a really tough math data set, they found that only that tiny fraction, just 2.3% of all the reasoning steps, had a high causal impact on the final answer. That means almost 98% of what the AI wrote down was decorative. It looked like work, but it barely affected the outcome. But wait, the story doesn't stop there, because the researchers, they weren't satisfied with just discovering this. They wanted to know if they could control it. Could they actually force an AI to pay attention to a step it was trying to ignore? And this is where we get into something called steering. The easiest way to think about it is this. Imagine the AI's mind is this giant, abstract map of ideas. That's its latent space. Steering is like being able to reach into that map and turn a specific dial that controls what the AI focuses on. So by comparing the AI's internal brainwaves during true thinking versus decorative thinking, they actually found a consistent signal, a kind of mental fingerprint they named the true thinking direction. And get this, by pushing the AI's internal state along this direction, they could make it engage more with a step, push it the other way, and it disengages.
And this is where it gets absolutely wild. Check out these tests. For the engagement test, they took a step the AI was ignoring, they put a little error in it, and then they steered the AI towards that step. And bam! The AI suddenly paid attention to the error and its correct answer flipped to wrong. Then they did the reverse in the disengagement test. They found a step with an error that was tripping the AI up, steered it away, and poof, the wrong answer flipped to correct. They could literally turn the AI's true thinking on and off like a light switch.
So, what does all this mean? This isn't just some neat lab experiment. This really fundamentally changes how we need to approach AI, especially when it comes to trust and safety.
So let's break down the big takeaways here. First, efficiency. Our AIs are wasting a ton of energy creating all this decorative reasoning that they don't even use. Second, and this one's huge, safety. We can't just read an AI's rationale and assume we know what it's doing. It could be planning something bad while writing out a perfectly harmless-looking explanation. Third, trust. The whole idea that we can trust an AI's explanation is on shaky ground now. But, and this is the good news, fourth, control. We are finally starting to develop the tools to maybe, just maybe, make AI reasoning more honest and reliable.
Which leaves us with this really deep question, doesn't it? We've built these incredible machines that can talk to us, that can explain themselves, but if we can't always trust what they say they're thinking, what does it even mean to understand them? And how do we move forward and build a future with AI that's based on real trust, not just a really, really convincing performance?